The oceans are changing, and the climate is changing. The West Antarctic Peninsula is a region that's experienced dramatic changes. For 17 years, we've been going down there using traditional technologies. We have a cruise every January, go down, map all the physics, map all the chemistry, map all the biology. So that gives us a snapshot every January. The problem is a lot of the things we want to understand happen at other times of the year. And so what we decided we had to do was to bring in new technologies to allow us to cover the times when we can't be down there on a ship. What we focused on was bringing in ocean robots. And gliders are robots that don't have a propeller. You can load them up with batteries and sensors, and they can remain at sea for months at a time, which allow you to fill in the gaps when the ship isn't there. What they do is they suck in about a coffee cup's worth of water in their nose, makes them just heavy enough to sink. When they get to the depth they want, they push the water out, makes them float. So they move by changing their buoyancy. In the middle of the glider is what we call a science bay. And this science bay carries whatever sensors we can essentially fit. And so we can track not only the physics, temperature, salinity, currents, but we're going to be able to look at the chemistry all the way through the biology, the phytoplankton, the zooplankton, the whales, the seals in real time. And we're going to be able to ask questions of how they're connected in a way we couldn't before. That will be revolutionary. So while you're not at sea all the time, you are at sea all the time. These gliders go underwater and then every so often come to the surface and stick their tail up in the air. And in the tail is a global cell phone. And that cell phone calls my lab in New Jersey. It'll download its data. It'll get a GPS fix, figures out where it is it off course, and then go back on its way underwater. And you can control these systems from anywhere in the world. Now we're building these control centers. Our control center is called the Cool Room, the Coastal Ocean Observation Lab. It's at Rutgers University. So students or scientists can be in New Brunswick, New Jersey, and they can be controlling robots anywhere in the world. And so a typical day in the Cool Room will involve the gliders calling into the Cool Room throughout the day, and you literally hear the phone ring, and it's literally just a long-distance phone call from this robot out in the Southern Ocean. We are checking where all the gliders are, wherever they are in the world.
That's a nice path, huh?
We'll take control of them, we'll adjust the flight, we'll ship the data to our partners. So we're constantly adjusting how we're sampling the ocean, who's getting the data on the fly every day of the year. So everyone can partake in the exploration as it's happening in real time.
So based on when they left, they think they're going to get to that point when?
Well, there's steam until 11. 11 or that point.
So this idea of being present anywhere in the world's ocean is now becoming a reality. What's exciting is to see the potential of how much it's going to change how humans relate to the ocean as a whole. When the climate changes, it affects everybody, all humans. It's an international problem, and often flying gliders is an international effort. We get data from international partners. If they have a glider in the water, we give them our data. And so we have this international climate problem, and gliders will probably be an international tool that will tie us all together and unite us in our efforts to understand where the world is going and how it might impact human society.